I always tell people I had the easiest job in the world teaching chemistry. I get to light things on fire and make them blow up and change colors. And it's pretty easy to keep people engaged.
One degree of separation. The lines all cross, the stories align. One degree of separation. Who's the next? You'll know in time.
Welcome to the sixth and final episode of this chain of the One Degree of Separation podcast. I'm your host, Ryan Murphy. On this podcast, we explore the theory of 6 degrees of separation and prove just how connected we all are. At the beginning of each 6-episode season, I'll begin with one fascinating guest, who after their interview will recommend someone they know who has an interesting story to tell. This creates a chain of connections and incredible stories. Join me on this journey by subscribing on your favorite podcast platform and on social media at One Degree Pod. Today, we're joined by a highly regarded chemistry teacher and coach at Elmwood High School in Illinois. We'll be discussing his unique approach to science education and how he inspires critical thinking in all of his students. He was referred to me by my episode 5 guest, Jack Cornell. Please give a warm welcome to Todd Hollis. Todd, welcome to the show.
Thank you for having me. This is wonderful.
So you referred to me by Jack. Tell me a little bit about how you know him.
A few years ago, Jack and I were both selected to coach in our state's all-star shrine game. We had never had even heard of each other. And then it's an interesting thing. You show up on a Tuesday and, none of the kids know each other. None of the coaches know each other. And by the end of the week, you're close friends with a few of them. And Jack and I really made a great connection. And over the course of the last several years, through a lot of texts and phone calls and seeing each other, we've grown pretty close. And I think mostly the reason we've grown close is our approach to coaching, and that our main focus is growing young men, and in the process, winning football games kind of happens. But at the end of the day, I always tell our players that it's about significance. It's not about success. Success is kind of what you see in the headlines, and significance is long term. And in 20 years, if I come back and I see our guys and they're good people and they're good husbands and they're good citizens, then that's significance. And Jack goes about the same way. So we really bonded over that. Yeah. So that's kind of how I got to know Jack.
So I talked a lot of football with Jack last week, but I kind of want to talk to you a little bit about your teaching career. How
Sure.
did you get into teaching?
So I actually was a business marketing major. I went to Bradley University in Peoria. And I would say now that I probably was one of those people that should not have. Academically, I was totally prepared for college, but I was floating. And so I went to Bradley and I was studying marketing because that's what my dad did and that's what my brother did. And I figured, oh, what the heck, I'll just go do that. And it's kind of crazy to think you're paying for college from somebody that has no idea what they're going to do. But in the process, I decided, hey, I think I want to coach football. I played football in high school, and I asked a friend in my fraternity who was from Peoria. I said, where should I go? And he said, you need to go to Richwoods High School because they had been incredibly successful. I called up Richwoods, and the head coach there knew my head coach because they had coached in the Shrine game together. So that's kind of crazy. And before the end of the first week of practice, this was going into my sophomore year of college, I knew that that's what I wanted to do the rest of my life. And I called my parents and said, hey, I want to change majors. And my mom was a teacher and she was all for it. And my dad was, he was a very prepared person, very much a straight and narrow path. And he wasn't real thrilled. My mom said, don't worry, I'll convince your dad it's going to be okay. So then the question was, what was I going to teach? How was I going to go about being a coach? Bradley, everybody thinks, oh, you're going to go be a PE teacher or whatever. But like I said, academically, I was in a pretty good spot. And so I just had to pick something. And I don't know if it was roll of a coin, but I was good in English. I was a good writer, but that didn't excite me a whole lot. And science did. I was always pretty strong in math. And chemistry just seemed like the one. I could have picked just about anything, but picked chemistry, probably because I really enjoyed my high school chemistry teachers. And the subject matter was pretty good. And at that point, dove in. And that's what got me into I got into teaching because I wanted to be a coach. There's part of me that thinks that sounds like it's not the right reason to get into teaching. But I think my experience has been most of the people who are really good coaches are also really good teachers, because we do the same things in the classroom that we do on the field. If you're successful, you understand how to break things down in a way that kids can learn them. You understand how to test them over and over again on it. You understand how to reteach them and identify problems. And that works both in the classroom and on the football field or track or whatever other sports. Because I've coached track also. So uh, I went into it because of coaching, and in the process found out that I really enjoyed chemistry. And the more and more I taught, the more and more I grew to love my profession. And so now when people ask me what I do, I think probably before I even tell them I'm a football coach, I'm a chemistry teacher, because I really love what I'm doing as a teacher. And the coaching is still, I mean, that's what got me into it, and I still love it. And I'm still doing it 29 years later. Already it's my 33rd year coaching football, but teaching was secondary, and then it's become equal to, for sure.
Okay.
That's
So
a long answer for you.
no, no worries at all. I love long answers. Less talking for me. So you mentioned that you were originally inspired by some of your own chemistry and science teachers. Tell me a little bit about them.
Well, I just found that in the labs, although biology labs, I really really enjoyed dissection, and that to me was pretty awesome stuff. But probably because that was more anatomy, so that was more of a related to learning the muscles and all of that, and that was something that as an athlete I was into. But I think probably in the chemical sciences you get an equal amount of the visual hands-on part of it and an equal amount of the mathematical part of it. And those two mixing together, I think I enjoyed some of the lab work and things like that. It was interesting, and they were just good people. I never had Lynn Nolan in Naperville Central. She was actually a biology teacher who let me do an independent study marine biology class with her. So she wasn't my chemistry teacher, but she had this biology background, and she was a great teacher. Mr. Wiesbrook was actually a track coach there, and I didn't run track, but I coached track actually once I got to Elmwood. So that's a very small school, and you find out when you're at a small school that you suddenly become a jack of all trades. And I saw, I remember seeing him at the state track meet one time, and Naperville's an 8A school, and Elmwood's a 2A or a 1A school. And he still remembered me, and he was my chemistry teacher, and he was very excited. He was a very excited person, the kind of guy that could work himself up into a sweat by the end of it. And he was an athlete. I mean, I guess maybe that's another thing I see is, here is this guy that was an athletic coach, and you knew he was an athlete, but he's also in the sciences. So maybe that run with me a little bit, that was something that I would enjoy going into.
Now, when you first got into teaching and you first stepped out in front of a high school class, what was the biggest lesson you learned right away about teaching?
The first time I stepped in front of a class was as not in my teaching prep classes, was at Limestone High School. The guy's name was Ken Baker. He's somebody that I ran into over and over and over throughout my career until he retired just recently. Ken was another person that very excited to teach what he was teaching. I mean, you could not be in his classroom. There was never a doubt that he loved what he was doing and that he loved the subject matter. And I think that always pays off for students when they can see that you get really excited about what you're doing. But the first time he put me in front of a class, I was going to do a couple of fairly common demonstrations. I don't know if I'd say the famous demonstrations, but you have a flask with some boiling water in it, and you put a balloon over the top of it, and the balloon blows up, and suddenly you can see, well, not only is hot air rising, but also as you heat things up, they're going to expand. And so suddenly it's one of those where these things that you've been telling students ever since they were little, heat makes things, suddenly they can see it, and that's pretty cool. And then you take it off, you put it ice, and the balloon goes back down inside the flask. And so you've blown a balloon into the flask, which would be impossible to do otherwise. And again, it's a very neat, it's an ooh and ah kind of a thing. And I'm up there and things are going well. And when I had taken it off of the Bunsen burner and put it into the ice, I was staying there talking. And obviously I was very nervous. Didn't want to put my hands in my pockets because I didn't want to be that person. But I felt the need to be moving, and the Bunsen burner was off, but I reached down and grabbed it, and I moved it, and I didn't say a word. I finished the lesson. At that point, that hand did go in my pocket, and I had a terrible, terrible burn. And that was a huge lesson. And Ken saw what happened, and he was like, I can't believe you kept going. I'm like, well, I wasn't going to, I couldn't freak them out, and I needed to stay calm. But that kind of reminded me, it taught me a couple of things. One, that the job of teaching is you have to keep doing the teaching. I mean, you need to finish lessons. Sometimes demonstrations are not going to go the way you want them to, and that's okay. When people think that science is always going to work the way you expect it to, sometimes things are really fine tuned, and if you have anything off, it's just not going to work. And sometimes it's a total flub and the teacher's human and they make a mistake. And fortunately, none of the kids even knew what happened, but man, I sure did. So that was my first time in front. And I still enjoy it because the demonstration itself was a success. And that's neat when you hear a couple of oohs and ahs in the crowd. That's a very, very neat feeling.
Now, do you tell that story to current students as kind of a warning of what not to do?
I tell that story to students as I'm doing that demonstration now. Yeah, so I still
Nice.
do that demonstration today, and yeah, I tell them exactly what happened and how you have to be careful, um and I don't, I think back, was it preparation? Did I not prepare? I was just nervous, and I wanted to move things with my hands. I needed to be doing something, and certainly, uh, I can step in front of a class. I've done this for so long. I could step in front of a class now, and I don't get nervous, right? Although if you ask me to step in front of a room of adults, I probably do get a lot more nervous. And I think that's funny because I think sometimes I hear adults who are not in the education field, like, I couldn't go stand in front of a bunch of teenagers. I'm like, man, that's what I do all day. That's easy. So I do think it's a little bit of a flip there. Yeah.
What do you think the difference is between kids and adults that changes your mindset?
Huh. I think through teaching and coaching, I think there's a certain amount of it that keeps you young. I mean, I'm certainly not up on the hip language and the apps and all that. Yeah, that's not there. But the same, I hear the same silly jokes, or at least the gist of what the jokes are. High school sophomore boys still laugh about high school sophomore boys stuff, and so you still get some of that stuff, and I have no problem laughing at myself. So I'll be full self-deprecating, and they get a kick out of that, um, and I guess maybe they're a little freer with their ability to be wrong, I guess, or to joke around. And I guess maybe sometimes I think you get in a room of adults and maybe it's a little bit less of that. Also, everybody in my class, I know what my audience is. I mean, we're all studying chemistry together, and I know where they are. I know where their knowledge level is, and we're all speaking a very common language. So if I were to step in front of like a group of football coaches and I was talking about football, that would probably that does feel very similar to me. But when I speak, I've had opportunities to speak in front of bigger groups that are quite diverse in whatever it is, not necessarily about science. And that makes me a little more nervous because probably I'm out of my comfort zone a little bit of what I do every day. And I'm not sure where all of those people are with what's acceptable in their professionally with, when they hear talks and things like that. So I guess at the end, I just try and be myself and hopefully it comes off okay.
Um, Now, as I was doing my research about you, I read about you have a famous demonstration you do about with a burning candle. Can you tell me a little bit about that? About that?
So yeah, so one of the best developments that ever happened to me. This is probably about 12 to 15 years ago as a teacher. Um, One, I piloted our school's one-to-one program, so everybody in my class ended up with a tablet. And that, there's debate about whether or not that should happen. But what ended up happening as a result was I got rid of the textbook, which meant I had to then develop the curriculum. Well, my school has always been very good about the degree of autonomy that they give the teachers. I mean, I'm the expert in chemistry in the building. I mean, if there's things in the chemical cabinets that I'm the one that's legally responsible for those because I'm the best chemist in the building. And so there's been a lot of autonomy. Hey, if you're the expert, as long as you're following a reasonable path, then go ahead and do what you want to do. And at that point, because I didn't have this textbook, I started teaching um, from stories. So I developed stories that were the background to units. And when I started doing that, it did a couple of things. One, it gave the students a hook. So everything went back to the story. So for instance, we're studying ions right now, but the story is the Flint, Michigan water crisis. So why is the lead ion bad? Well, now everything goes back to that. So the chemistry of fire is what we teach, how I teach organic chemistry, and that's after Christmas. And in the process of doing chemistry of fire, it dawned on me one time that just sitting and watching a candle burn, humans like fire. I mean, we become captivated by fire. And when you watch a candle burn, and you really watch a candle burn. So we have a day where I just turn the lights off and they light a candle and we just sit and look at it. And we look at it, we look at it, we look at it, and they draw it and they describe it. And in the process of doing all of that, they start to realize some of the things that they thought were going on or not going on. some of the things that there are definitely some things that surprised them. And then in my own research, because that's the neat thing about developing these stories, I'm continuing to grow. So I'm continuing to look into the stories. Michael Faraday, who was in the 1800s, was probably the first what we would call science. He's not a science influencer because that has a definite negative. He's the first science communicator to the masses, and he started a thing called the Christmas lectures at the Royal Institute in England, and it was normal people, especially kids. He brought kids in and wanted to do science for kids. So you think about where we are, this mid 1800s, early 1800s, and education levels. It's not public education. So he's trying to bring just normal people in and teach them about science. And he did an entire set of Christmas lectures on the chemistry of candles and candles burning. And so really this lab that I came up with, I mean, Michael Faraday is really the one that did that. He started the idea. I didn't happen on his story until after I was kind of doing this thing. And then I've then taken a one row further than that. And now I have them burn the candle, light it on fire, but put it on a scale. And in the process of doing their lab, from the time they start to the time they end, they look down and the scale has literally lost mass. And I can show them how we can then calculate how much carbon dioxide was released based on the mass that was lost, because we know that candles are made of paraffin wax. Paraffin wax has a general organic chemical structure. You could do some mathematical calculations. And then that transfers into when you see the headlines about how many millions of tons of carbon dioxide are released in the air when the Amazon rainforest is slash and burn. And so that's kind of get to that story. I'm like, guys, you've seen these headlines. And for some people, they probably seem like, how would you ever know that? And then we do this lab. And like, oh, yeah, you can see the mass disappearing and it has to go somewhere. And suddenly they can take the headline that they see that looks fantastic and actually have the science understanding of what's behind it and be like, oh, yeah, no, that's very real. That's not, scientists waving their magic wands. That's a very real thing. And I can do that calculation. So that is a very, very neat lab. And there's some other stuff we do with candles that's pretty fascinating, too, that in the end, the kids, I think, walk away from it. And every time they light a candle the rest of their life, they'll probably think a little bit about it.
Yeah, it definitely sounds very interesting. Now, I'll admit that when I was in high school, my mindset was always just memorize the fact, take the test, move on. How do you change students' mindset into thinking more like a scientist?
Well, one thing I do is, for the most part, at least with my first year chemistry students, if they take notes, they're allowed to use them. And the reason I say that is once they take the notes, they own them. It's kind of the difference between when you're writing your English paper and you've learned the content well enough that you don't know who you would cite because it's actually your own thoughts at this point. So you're not citing a specific source. So if they've taken the notes and they understand the notes, and I don't put, I'm not a person who puts PowerPoints up on the screen and say, copy this down. These are notes through me talking and a little bit of lecture and some notes on the board and all that. But I'm constantly telling them, hey, if all you're doing is copying the PowerPoint down for any class, all you're doing is practicing your handwriting. I mean, so just copy the PowerPoint. That's it's a waste of time. You need to, brain science tells us you need to rearrange the words, put it in your own words. I'm a huge fan of changing colors. So I'm constantly on my board for changing colors. I show them some of my college notes, my college notebooks, where even then I was changing colors. So I'd write in black for my general notes and underline with red and go to blue for other things. And so I try and teach them a lot about how the brain works. And I said, guys, the periodic table is in every science lab in the world. And if it's not there, it's on their phone or whatever. And chemists, not just chemists, scientists, use the periodic table all the time. And it's a massive cheat sheet that's been around for 200 years now, or almost. And if scientists are going to understand that it's just a tool, that if I happen to forget the mass of cobalt for some reason, that I would suddenly stop doing my job for the day instead of just looking it up. It doesn't make you a terrible scientist. The unwillingness to go look it up makes you a terrible scientist. So I try and get it through to them that all these things that we have in front of us are just tools. And so I never ask a question that they already have in their notes. They might be able to use their notes to get to the answer, but they're never going to find the answer to a question that I ask in their notes. So I think one of the things there is teaching them that how to use the information to answer questions they haven't already seen, how to use the periodic table to answer questions they haven't already seen. That so much in science is trends, and the first time you learned the Pythagorean theorem, it works for every right triangle you've ever seen. So you didn't have to copy down a whole bunch of options. You just had to copy down one example. And then pull that example out. It works for every other right triangle you ever see. And there's a lot of that in chemistry too. Once you know a general trend, that trend is going to work over and over and over again. So you can make these predictions based on prior knowledge. Those predictions might not always be right, but they'll be pretty close most of the time. And that's honestly what science is. It's humans trying to record the observations that we can see and we can test over and over and over again, to give us the best possible answers and predictions. There are going to be outliers always, and that's okay. Sometimes those outliers are because we were bad experimental scientists, and sometimes those outliers are just outliers. It doesn't make the science bad. I think any scientist that says they know the answer 100% all the time, they're not a good scientist. It's the ability to say, I'm pretty sure I know the answer, but almost any research study you see at the bottom says, hey, but more research is needed in this area, in this area, in this area. And they're always, the scientists are always looking for what's the next step? What's the next step? What do we need to go check now? So your question was about memorizing facts. I tell them, I say, guys, don't flashcard anything in my class. We don't need to flashcard. We need to learn how to just generally speak the language, and you will figure it out as you go.
A lot of people have different styles of learning, both in school and in the real world. How do you adapt to different people's styles?
Well, there was probably 20 years ago, maybe longer than that, there was a theory that came out in education. It was this learning styles theory that people had. You're an auditory learner. And in that there was a triangle that came out. And you've probably seen it. Says something like, you only retain 10% of what you hear, but you remember 90% of what you do, right? And there's this triangle that came out and all this stuff. And really, at the end of the day, because I did the research on it, because I said, where did they come up with those numbers? And a lot of those numbers, the guy that actually created this triangle specifically or explicitly said, this is a general idea, but it's not the answer. And there's no experimental evidence for any of these numbers. Those numbers came from somewhere. So the idea that people are always going to learn a certain way, that they have a preferred learning style, I think some educators went to the point they're like, well, I need to teach this group of students auditory, and this group of students hands-on, and this group of students and really what you need all of it. Everybody needs everything. Actually, more recent research I've seen is you're going to do your best learning when you're given the information that is not your preferred style, because it's not going to be easy for you. It's going to be more like going in the weight room and lifting weights. You need to do some hard lifting for your brain to make the connections that it needs to make, because if it's easy connections, your brain's not struggling. If your brain's not struggling, then it doesn't need to go reach this past idea over here and this and then try and tie them together. So I think the brain science now is showing us that preferred method is not always the way. That sometimes the other methods forcing you, right now I'd say the big thing is forcing students to sit down with a text in front of them is the preferred way, because you have to do that hard lifting. But at the same time, I take my students a lot of times on podcast walks, and we'll go outside. We just listen to podcasts on why do the leaves turn, why aren't they green right now? Why are they changing colors? Well, now we're out walking in nature and we're seeing it happen in real time. And the scientist is telling us what's happening in real time. And I don't know if that's hardcore learning, although it's experiential. I mean, they're going to remember it. I've had students come back to Mr. Hollis, I saw it again. I know exactly why. And this is the next year they come back and tell me. So, I mean, I think it needs to be a blend of all, but I definitely don't believe in the idea that you tailor your lesson, you send those kids over to that side and these kids to that side, because I think we all learn across all different methods. Those of us that went to college and did well were good at going to school. I think people need to realize that people who go to college are probably good at going to school. We're good at sitting in a lecture hall. And you have people who say, oh, you shouldn't lecture. And I'm like, you know what? If you gave me 30 minutes and told me I had, there's a lot of every football clinic I go to, it's 45 minutes of the guy talking. And there's no way I could get the amount of information in 45 minutes if I didn't go sit my butt down and listen to that guy lecture and take notes. So sometimes that is the best way to do it. And it's honestly, to get that much that fast is probably the only way to do it. Now, then there's other times that you need a deeper dive or you need the physical explanation. But I think that's what the science classroom allows you to do is you get the board work, you get me explaining, you get to watch some documentaries, you get to go back in the lab and do it. And I think that's why, I mean, I always tell people I had the easiest job in the world teaching chemistry. I get to light things on fire and make them blow up and change colors. And it's pretty easy to keep people engaged. But it's also, I think the sciences are also set up just naturally that they do all of they hit on all of those modalities that people see as their learning styles.
Kind of along the same lines, you teach both introductory and advanced classes. How do you change your teaching style for students who are new versus the ones that are ready for the more advanced stuff?
Well, so I'm it's a small school. So we have 180 kids in the high school. So sophomore year, I will teach every sophomore. So that's physical science, so introductory physics. So let's just take chemistry, for example, one, I know that all of those students come into me mostly not knowing any of the stuff, or they've seen a little bit in the past. I think a lot of high school is you take these little bits that we fed you in the past, and now we're going to dive in and really get it. And we're going to start to get in the weeds a little bit. So I know that all of those students are on the same level, right? And so I can start from zero and then I can kind of build them all up. And so then when they get into my chemistry class, there's a lot of the stuff from physical science that comes back in chemistry. And I say, hey, you guys all remember when oh yeah, I remember, so the nice, yeah, some people say that the small school is bad because you have the same teacher 3 years in a row. But the nice thing about it is you have the same teacher 3 years in a row. So we're truly building on the same knowledge and the same experiences. And so when I get my seniors, they will have all just had me their junior year in chemistry. And when they walk in, we're all speaking the same language. They know all, they've all done the same labs. They've all heard the same stories from, Flint, Michigan and Chernobyl. And, we've done forensics and serial killers. Like they all know that stuff. So what I'm now is in the advanced. Okay. So I guess the difference being the advanced class, now we're diving into the stuff that's less story related and really probably more hardcore science related. They were like, all right, so we had the story and here's where it went. Now let's get into the stuff that's really, really diving in there. And that's probably the difference is that, I always tell them, I say, when you guys were in kindergarten or in third grade, you're in third grade, we gave you this model of the atom, the Isaac Newton model, which was it's the smallest piece of matter that can't be divided. I said, well, that's all your little noggins could handle at the time. You couldn't have handled that there were orbitals and electron shapes and all that. And I said, you couldn't have done that. And there's the junior high version of the model, and that's all your noggin could have handled. And then there's the high school version of it. I said, and then you go to physics, and it's all quantum stuff, and none of this stuff is real anyway. And so I said, we're only going to give you what you can handle at that point, and you have to have all this prior knowledge to understand where we are now. But if I were to tell you everything I know in the first step, you're not going to understand. And there's levels where I say, guys, I don't understand some of this, and I'm not going to pretend to, and it's out of my realm. We get into that quantum mechanics. Like, no, that's not me. That's physicists. That's not chemists anymore.
Now, hands-on lab work is obviously a very big part of chemistry. What's your philosophy for finding the balance between making it exciting and also keeping it safe?
I tell my students that they're to the point. There's some chemicals that we will get. We'll get some chemicals out, and I'll say, all right, we're going to use some silver nitrate today, and we'll all sit and read the warning statement, and it says right there, it says, hey, this stuff is toxic. So we have hey, what does this mean that's toxic? And well, that means it could kill you, Mr. Hall. I said, yes, like you guys are doing adult level science at this point. You're 16 and 17 years old. There's no saying that even if you don't go to college, you could go be a lab tech somewhere and you're going to be dealing with real stuff. So let's not be shy about this potentially dangerous chemical, but let's also talk about how you have to be safe. And so the big one there, hey, you take your goggles off, you get some of the stuff in your eyeballs, and the silver nitrate turns black because that's what they used to use in black and white photographic film. And your eyeball turns black. There's no giving you a new eyeball. Like it is what it is. So I think, I think you treat them as young adults because that's what they are. They're not kids. They're young adults, and explain to them the dangers of it and that there's no room for messing around when we go back in the lab. When we do the unit on fire, I tell them my goal is to have a fire in class every day. Either I'm going to have the fire, we're going to watch the fire in a video, or they're going to have the fire. And we have a lot of discussions about, how careful you have to be and that we can't screw around in the lab. And fortunately, I don't have issues. I think they realize that when I I'm usually pretty fun and easygoing, and I give them a lot of warning. Like when we go back there, this is very real adult level stuff, and you have to treat it as such. Also demonstrating ahead of time. Hey, here's how you do it. Don't. That's probably the early in my career I realized how far away my experiences are from what students have. You forget how little you knew. It still blows me away today. Well, the kids that don't know how to light a match. I'm like, well, I play with fireworks all the time. Army figures got blown up all the time around 4th of July at my house. But there are a lot of kids that haven't lit matches before. Maybe they use lighters, but they certainly don't know how to use matches. So all right, let's all learn how to use a match. That's probably a skill as adults we ought to have. And so we have a little last match lighting process, but our contest. But I think some of that too, like realizing that I know and I forget that they don't, and I have to be very aware of what I know and what they don't know.
And I'm sure you obviously have the fire extinguisher very close by.
Well, and yes, and that's another thing that you talk about is, when we do the chemistry of fire, the first thing we do is, hey, what are the different fire extinguishers and why do they work? And I go show them our fire extinguishers and what they can put out, what they can't put out, fire blankets, where the fume hood is, all that. And I think that, and then I can talk about it. So those of you that take our shop classes, walk in there. They've got the same fire extinguisher in there because you have the same chemicals in the shop class that you have in the chemistry class. You have organic compounds that can catch on fire, gasoline and oil and stuff like that. You have metals that can get really hot. They probably won't catch on fire, but you got to be careful about them. So even in the art room, there's times in the art room that you're using some chemicals. So I think that probably is one of the more important things is there are a lot of careers you could go into, whether it's food service industry or farming, things like that, that safety equipment is a must. Knowing where it is and that it's going to work is a must. Having a clean area that you're going to work from. I remember my grandpa was a farmer, and I always, my dad, it drove my dad nuts because my dad was definitely everything has its place. And my grandpa always used to say, where's that such and such tool? He's like, well, it's wherever it was the last time I used it. Well, that's not really the safest way to go about life. You probably ought to clean up your area when you're done, so that means where it's supposed to be, so the fire extinguisher is where it's supposed to be. But then, I think that you bring up a good point that if we're preparing kids for their adult life, at some point we have to give them adult experiences, and some of that happens through lab work, especially in the chemistry lab. You may not get as much in the physics lab. It's a little bit in biology because you're dealing with some chemicals when you're doing dissections and things like that. And so there's some other chemical stuff that happens in there, but definitely in the chemistry labs, I think maybe one of the first times other than shop class where you could really get injured if you're not careful. And I think the shop teacher and I have a very similar, he's an easygoing guy until we're going to go back there and play with saws or play with chemicals. And at that point, it's really not play anymore. We need to really be locked in.
Have there ever been any experiments you've done or wanted to do that the school just shut down for safety reasons?
No, although I did used to there's a demonstration, sodium, the metal, not sodium that you get in your salt, sodium, the metal. When you put sodium in water, will catch on fire and sometimes it will explode. Not massive explosions, but pretty good. Well, when I first started, I did the demonstration in my classroom, and fairly tall plastic bucket, which makes it, you use a tall, thin plastic bucket, so it's more of a rifle and less of a shotgun. So when the explosion happens, it goes in one direction. And I looked up and a chunk had hit the ceiling. The ceiling's made of wood, and that stuff is now sparking a little bit. And I'm like, wow, that's not good. So from that point, I said, you know what, we'll just do this experiment outside from now on. And so we still do it, and we do it outside. It's behind all the safety stuff that's supposed to be behind, but we do it outside, and we stand upwind from it. And which actually, that's another learning thing, because it lets me talk a little bit about things like World War One. We're using, they're using gas, and why did gas work in World War One? Well, you waited until the wind was blowing in the right direction. I said this stuff we're using here would make you choke and cough and whatever, and then you get chlorine gas in World War One, and so they kind of see how that can be an issue. I'd be very careful with it and how dangerous it can be, for sure.
Yeah, absolutely. Now, you mentioned at the very beginning of our episode that you also, and you've mentioned a few times that you also coach football and track and field. How do you balance those two with teaching as well?
Well, I mean, they're extracurricular, right? So, I have to maintain that's gotten easier. The longer I've done this, I've figured out you do it long enough, you figure out the easy balance, and you get a lot of systems in place so that things don't creep up on you. But my primary job is to teach. I'm there to teach, and football is nice, but it's also, 3.5, 4 months of the year full time. And it is extracurricular. It's after school, but it's also time consuming. And what I have figured out is, that I'm a person who's a very early riser. So I tend to do a lot of my football related work before anybody's up in my house. I try and get up early and get it done. I'm not an alarm clock person. I just wake up. And so I wake up and that's when I do my football work. So I'm trying not to take away from my family. I know early in my career, I probably was not great at that. I let some things, when my kids were young, I was probably a little bit too obsessed with some of it. But as I've gotten older, I've gotten more relaxed with that. And I've just gotten better at focusing my time and using it more wisely, not working harder, working smarter. That thing is very true. The other part of that is part of teaching is relationships. Sometimes making relationships in the classroom is difficult because you're in this academic mode where you're getting through information, you're getting through the stuff, and then, hey, now we're going to practice it. Now we're going to test on it, quiz on it, do a lab on it, whatever. There's not a ton of time to just be with the kids, especially when you have a class that's 35, 25 kids or whatever. There's just not a lot of time. And it's not set up that way. In sports, there's time walking down to the field. There's time walking back from the field. There's time where you have, water breaks. There's all these other, on the bus, whatever. And I think that for me, I know some teachers are very good at making relationships in the classroom. I struggle a little bit with that, but I'm much better with it as a coach, I think, because it's a more relaxed environment and there's just a lot more opportunities.
Now, you emphasize leadership and character development both in the lab and on the football field. What does a leader look like to you when it comes to your students, and how do you encourage those traits?
Yeah. So let's take lab, small group work. That's one of those things that we all remember doing small group work and somebody in the group didn't do much work and somebody did all the work. And that's really kind of a pain. That kind of stuff, I always tell my students, I said, hey, it's not fair for anybody if somebody's not pulling their weight. If they're not pulling their weight, you just send me an email and let me know, and I won't penalize you for not having their part done, and they won't get credit for having your part done. I will grade them on their own work. I think in doing that, one, it gives them the opportunity to not get frustrated, right? But it also opens up some avenues to talk within the group of, hey, come on, we all got to do this. None of us want to send the email to Mr. Hollis. And maybe that gets some kids talking that wouldn't normally. So I feel like that's empowering. You tell them they're allowed to have a voice. The other thing I think leadership in the classroom is getting students to understand that it's not just their grade, that hopefully getting students to realize that helping other people is a good thing. Your strong students being willing to help your students who struggle a little bit, that helping them is a good thing, and that helping them actually makes them understand more, that when you can teach it, then you really know it. Yeah, that would probably be the biggest. If you were to ask me who's the leader in the class, I'd say it's probably the students who are willing to go help other students, not just their buddies. That when they get into a group, that they're willing to go do a little bit of help. We have our community is very strong. Generally speaking, Elmwood's a great place to live. It's a great place to teach. I know I'm blessed, and we have a lot of kids that are willing to do that. Also, when I see that, I make a point of giving that person a pat on the back. I think and that's another one. I think those experiences when the teacher or coach would have ever, anybody that walked up to you, privately and said, hey, that was a really good job. I mean, that means the world, I think, to students to hear, that they did a good job, that you're proud of them. Whether you're their favorite teacher or not, that's an adult that walked up and said, I noticed you. I've had two, the interesting thing with chemistry is, I every once in a while I get, oh, my son or daughter is not going to be a chemist. This is my 29th year. I've had two people go into professional chemistry, and I think I'm fairly good at what I do, but the number of people in the world who go on to become professional chemists is very small. So I've had two that went on to major in chemistry and then went into industry. So for the most part, I'm not teaching future chemists. So I need to make sure that I teach chemistry and science in general in a way that makes better citizens, makes better thinkers. But the two that did go into it, there was a moment where I stopped both of them in class and said, "Hey, you are really good at this. I hope you keep after it, because you're very, very good at science." And both of them have told me that that's one of the reasons they went into it was because I stopped and told them, and they both happen to be women. And that's honestly, that I think that's pretty awesome because it's an underrepresented, women are underrepresented in our field. And the fact that both of them went on to be my only two professional chemists, I think is pretty sick and awesome.
Yeah, that's incredible for sure. As we start to wrap things up here, I definitely wanted to ask about the program that you and your wife founded, the Blackout Disability Awareness Program.
So in 2006, my daughter Meg was born. And after she was born, we were told a couple hours later that she had Down syndrome. So we didn't know that was going to happen. Fortunately, my wife was already through her job involved with Easter Seals on kind of a volunteer basis with some student groups. So we at least knew that we could call Easter Seals. Um, we think a lot about our lives that we've been a little bit blessed that it seems like we've known people that have been able to help us down paths, especially in this with children with disabilities. So we got hooked up with Easter Seals, and Meg was going to Easter Seals within the first month. Was getting services that kids need that have Down syndrome and other kids with different disabilities. And after a little while going there, I happen to, as you're walking through for therapies, I walk into a room and I see a girl who has cerebral palsy, and there's a hula hoop laying on the ground, and she, for the first time, stepped over the hula hoop from the outside to the inside. Now that's that far that she was able to step, and the cheering that went up in that room, mom, dad, brothers and sisters, the therapist, that was this massive feat. And I thought to myself, that's something I would like our football players to see because we've got the biggest, baddest dudes walking the halls, and to see that girl gave like literally, so I'm going to give 100% effort. Well, that was as close to 100% as you're going to get. That took not only every ounce of, mental and physical and everything, the time it took for her to get to that achievement. I said, I want our guys to see this and I want them to appreciate all the things they have. So we started doing a little bit of fundraising and that. And then, the guys told me like, Coach, this is really meaningful. We want to do more, and so one of my assistant coaches had seen the Penn State whiteout, they do. He said, well, why don't we do a blackout? I thought, that's because we're black and orange. I said that's awesome. And it started up, and the first year was very successful. And I thought, you know what, this is a cool thing. The fraternity of coaching is pretty strong. And so I started asking other coaches in the area, and it's grown and grown and grown. And so what everybody does, you sell black T-shirts. People wear the T-shirts to the game. Uh, Easter Seals get some money, which is wonderful. Relatively speaking, fundraising wise, we don't make much of money compared to some of the other fundraisers. But I think over time, so I think our 15th year, and from Elmwood alone, we've probably sold over 40,000 T-shirts. And those T-shirts all have the Easter Seals logo on it, and our mission, which is to turning off the lights, blacking out Friday night to turn on the lights for disability awareness, understanding, acceptance. And I tell our guys all the time, I say, guys, whatever the money is, that's going to come and go. And there are people with more money than us that can give. I said, how often do you guys see those T-shirts when you're out in Peoria around town? They said, oh yeah, I see those T-shirts everywhere. I said, everybody standing in line behind somebody wearing that T-shirt sees that message and is planting seeds, because I told us, guys, somebody in this room is going to have a child with a disability. That's just, statistically, I have 60 guys in the room. You're going to have somebody who's going to, more than one of you are going to have kids with disabilities. And if that means you know where to go because you were part of Blackout, that there's a place you can call. That's something that a lot of people, we were fortunate, but there are a lot of families that didn't. Well, I think in Peoria, 40,000 shirts floating around, there's a lot of people that know that there's a place I can call for disability education.
That sounds like an incredible program for sure. Now, if someone listening right now wants to find out more, possibly contribute, where can they go?
If they search on Facebook for EB Football, and EB Football is also on Twitter, then that would be the easiest way to get a hold of me. Usually the best way to do that is actually I would ask your local high school if they're interested or they've heard of it. If they haven't, I would love to help them get set up with it because that's one of the things that's happened. Across central Illinois, we've raised over $400,000 since it happened because a lot of schools have gotten involved. A couple of the suburban schools in Chicago are involved. So really that are getting hold of me at thollis at elmwood322.com. And I can do whatever I can to help.
Thank you, Todd, and thank you so much for listening, everyone. This marks the end of this current chain of stories. We started in the world of drag racing and talked to everybody from powerlifters to business owners and educators. I hope you enjoyed this journey as much as I have. I will be taking a brief break for the holidays before releasing the first episode of the next chain in January. See you all again then, and I wish you a happy holidays.